Hello Math Analysis students. In this video we are going to work through the problems on page 2 of the unit review for conic sections. Now you'll notice that the problems on here all say to write the equation in standard form, and they say you do not have to graph the equation. You do not have to graph, but a graph is provided for you, and I strongly suggest using the graph. Notice also that these include some information about vertices and foci. Remember that foci is the plural of a focus point. So just to recap for a moment, going back over here, for the equation of a circle, we have our information right here with our center hk and our radius r. For an ellipse, and by the way, there's no foci on a circle. They only come on ellipses and hyperbolas. Right here is a brief recap of the ellipse information. Ellipses can be horizontal or they can be vertical. That depends on whether the bigger number is underneath the x term or whether the bigger number is underneath the y term. There is some important information right here. The center is always hk. The foci are at the point h plus or minus c in k if it's a horizontal ellipse, and h k plus or minus c if it's a vertical ellipse. And c squared is equal to a squared minus b squared. And for this, we really want to remember that if our equation for an ellipse, if there is a plus sign in our equation, then our ABC relationship has a minus sign in it. And for a hyperbola, here is our basic information here. The equation looks very similar to the ellipse equation, but there is a minus sign, and that is significant. If there is a minus sign here in our equation, then our ABC relationship is going to have a plus. And for these, the foci, once again, are h plus or minus c, k if it's horizontal, and h k plus or minus c if it's vertical. You do need to know what a, b, and c represent. A and b represent the distance from the center to a vertex, and c represents the distance from the center to a focus point. Okay, so with that in mind, let's get started here. On our first problem, this is an ellipse. The vertices are plus or minus 8 and 0. So you might find it helpful to write this out. This plus or minus 8 and 0 can be written as 8, 0, and also negative 8, 0. So when we plot that, 8, 0 is here, negative 8, 0 is here. These are vertices. And for the foci, plus or minus 2, 0. Again, we could write this as 2, 0 and negative 2, 0, because plus or minus is actually two values. So 2, 0 and negative 2, 0. Now right away, we know a good bit of information about this. Since we know it's an ellipse, we can tell the center, and we can tell that this is going to be a horizontal ellipse. We can tell that our center is going to be at 0, 0. That's the midpoint of our endpoints and the midpoint of the foci, and also just from looking at the graph here, it's right here in the center. So we know that our center is 0, 0. And also we know that it is a horizontal ellipse. Because the foci lie on the major axis, and in this case that is horizontal. So we can go ahead and get a pretty good part of our equation. We'll write since our center is 0, 0, that means we're going to have an x squared over something plus a y squared over something equals 1. Now the amount we go out left and right, that number squared is going to go underneath our x value. So we can count that here from the center. It's left 8 and right 8. So that means that our a value is 8 and a squared is 64. That's how much we go left and right. So that 64 goes underneath our x term. And then for the how much we move up and down, we don't really know that. We're going to have to calculate that. From the center to our vertex point, we said that was our a value, which is 8. And from the center to the focus point, that's our c value, which is 2. Since this is an ellipse, we know that our relationship here, c squared equals a squared minus b squared. And we know what a and c are, so we can just plug those numbers in. C squared is 4, a squared is 64, minus b squared. So when we calculate here, then we get, of course, that our b squared equals 60. So b would be the square root of 60. We don't actually need that, though, because the number that goes underneath our y squared is b squared, which is 60. And so our equation would be x squared over 64 plus y squared over 60 equals 1. All right, moving on to number 10. This is a hyperbola. The vertices are at 0, -1, and 0, 1. Okay, so 0, -1, and 0, 1. And the foci are at 0, -3, and 0, 3. So this tells us a good bit of information already. Again, we know it's a hyperbola. We can tell that the center is 0, 0, because that's right in the middle of our foci. And our vertices. And we can tell that this is going to be vertical, so that it would open up and down. And since it's going to be vertical, that means that our y squared term needs to come first. So we would have our y squared, y minus h squared, but since it's 0, then y squared over something minus x squared over something equals 1. And now we need to find out what are those a and b values. So let me go ahead and plot my center point here also. Now, you might find it helpful to label what these points are. The vertices were at 0, -1, and 0, 1. So that's a vertex point, that's a vertex point, and these green points I have here are foci. Now, the distance from the center to the vertex, that is our a value, which is 1. And the distance from the center to a focus, that is our c value, which is 3. So when we calculate this, we know that our relationship for a hyperbola is c squared equals a squared plus b squared. So c squared, that's 9. A squared, that's 1 plus b squared. So when we solve this, we get that b squared equals 8. So in our equation, our a squared will go underneath our y squared here, which is 1. And our b squared is 8, goes underneath our x term. And so this is our equation right here. Moving on to number 11. This is a circle. The center is -3, 2, and a point on the circle is 7, 5. Okay, the center is at -3, 2, and a point on the circle is 7, 5. This is a big circle. We don't know, if we try to draw the circle, it wouldn't fit on here. This point over here is our center, and this segment right here between this point and this point, this is a radius of our circle, so I'm going to kind of draw that in. I didn't draw it so great, but we need to find this right here. Now there's two ways that we could do this. We could use the distance formula, and our distance formula is square root of x2 minus x1 squared plus the square root of y2 minus y1 squared. And then you would plug in your coordinates. Doesn't matter if you call this center point x1, x2, and this other point on the circle y1, y2, or if you flip-flop those, doesn't matter. But you do need to be careful with your signs, which is where some students struggle with that. So I'm going to actually recommend we do this in a slightly different way. To find this distance, we can use the Pythagorean theorem. Now the Pythagorean theorem is a squared plus b squared equals c squared. But we only use that when we have a right triangle. And you may be thinking, but I don't have a right triangle. But we can just draw a line straight down, a line straight over from these points, and then we will have a right triangle. Straight down and straight over. And we have a triangle. And now we can measure how long these sides are right here. This side is 1, 2, 3 units long. And this side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units long. And then we just use these as our A and our B. Doesn't matter which one's A and which one's B. 3 squared plus 10 squared equals c squared. That's 9 plus 100 equals c squared. So 109 is c squared. Now if you wanted to go further, c is the square root of 109. I will write that in here. That is our radius, which is the square root of 109. But when we write our equation, we need x minus h squared plus y minus k squared equals r squared. So we're going to have to square this again. Our equation, when we write this, remember that we need the opposite signs from the negative 3 and 2. So this will be an x minus 3 squared plus, excuse me, that should be x minus a negative 3 squared, which would be an x plus 3 squared, and a y minus 2 squared, and the radius squared. Since the radius is square root of 109, then our r squared would be 109, and that is our equation right here. All right, moving on to number 12, we have an ellipse. We have our major axis endpoints and our minor axis endpoints. Major axis endpoints are 7, 8, and 7, 2. So this is going to be our major axis right here. And our minor axis endpoints are 6, 5, and 8, 5. So this is our minor axis right here. If you want, you can go ahead and connect them and make that ellipse. We don't need to do that. We can tell from this that our center is at the point 7, 5. This is a vertical ellipse, so our bigger number is going to go underneath our y term. But to go ahead and set up, this is going to be x minus 7 squared over something plus y minus 5 squared over something equals 1. And the number under the x is going to be a squared, represented by, a is represented by the distance from the center to the vertex, which we can see right here. This is going to be 1. So 1 squared is 1. And vertically, 1, 2, 3. 3 squared is 9. And so our equation would be x minus 7 squared over 1 plus y minus 5 squared over 9 equals 1. That is our equation right here. And number 13, we have a hyperbola. We're given that the center is at 1, 3. So this is the center point. And we know that a focus is at 6, 3. This is a focus point. And we know that we have a vertex at 4, 3. So, we can tell that this is going to be opening horizontally because it opens up left and right. The focus must be inside the parabolas. And so we can go ahead and set up our equation since we know that the center is at 1, 3. Since this opens horizontally, left and right, our x needs to come first. So we'll have an x minus 1 squared over something. Minus, that has to be a minus. It's not a minus, then that's the equation for an ellipse. That's a y minus 3 squared over something equals 1. Now to figure out that a and b, now we need to really look at what we're given right here. The distance from the center to the vertex, this is our a value, which is 1, 2, 3. And the distance from the center to the focus point, that is our c value, which is 5. For a hyperbola, our ABC relationship is c squared equals a squared plus b squared. So we plug in our numbers. C squared, that's 25. A squared, that's 9, plus b squared. And when we solve this, we get that 16 equals b squared. And so, underneath our first term is our a squared, which is 9. And underneath our second term is our b squared, which is 16. And this is our equation. And there you go. All right, good luck.